Hey everyone, welcome. Today we're tackling a super practical skill, something that's going to be a game changer if you've ever wanted to fix your own electronics: how to test a transistor. It's so often the culprit when things go wrong, and the best part is, all you really need is a simple digital multimeter. So let's jump right in.
You've been here, right? We all have. A piece of gear you love just stops working. So you pop it open and you're staring at this, a crazy, complex-looking jungle of tiny components. It feels totally overwhelming. But here's the thing. A lot of the time, the problem boils down to just one or two little failed parts.
So here's our game plan. First, we're going to identify this silent culprit. Then, I'll let you in on the simple two-diode secret that makes testing it a breeze. After that, we'll walk step by step through checking both NPN and PNP types. And finally, the moment of truth. We'll learn how to read the results to get a final verdict, good or bad.
Okay, let's dive in. When you're looking at a faulty circuit, the transistor is honestly one of the very first things you should suspect. Think of it as a tiny little electronic switch or maybe an amplifier. It's doing a lot of the heavy lifting, which also means it's a really common point of failure. And here's the best part. You don't need some fancy, expensive lab equipment. Nope. All you need is a standard digital multimeter, a DMM. The only key is making sure it has this little symbol on the dial. That's the diode test mode. That setting is the absolute magic ingredient for everything we're about to do.
Now, this is where it all clicks. You see this little three-legged component, and it seems like it's going to be complicated to test, but it's really not. It's all based on one brilliantly simple secret.
And I'm serious about this. Don't let the technical name, bipolar junction transistor, intimidate you. Once you see the principle behind it, checking them becomes totally second nature. It's awesome.
Okay, so here it is. This is the big secret. A BJT basically just acts like two diodes that are connected back to back. See, you've got two junctions inside, the base to emitter junction and the base to collector junction. So when we test a transistor, what we're really doing is just testing those two simple diode junctions. That's it.
All right, let's get our hands dirty with the most common type you're going to run into, the NPN transistor. And that name, NPN, actually gives us a huge clue. Just think negative, positive, negative. That positive in the middle is going to tell us where to put our positive probe.
The whole procedure is super straightforward. First things first, grab your multimeter and flip it to that diode test setting. For an NPN, remember positive in the middle, so your red positive probe goes right on the base pin. Then you're just going to touch the black negative probe to the other two pins, the emitter and the collector. And of course, the final crucial step is to swap the probes and check again to make sure current is only flowing one way.
So with that red probe on the base, when you touch the black probe to the emitter, you should see a reading. Then touch it to the collector. You should see a reading there too. For a healthy transistor, you're looking for a small voltage drop, somewhere around 0.6 to 0.7 volts. This is great news. It tells you that the internal junction is working like a one-way street, letting current pass in the correct direction.
Okay, but here's the other half of the test, and it's just as important. Now you swap them. Put the black probe on the base and test the other two pins again. This time you should see OL on your meter, which means open line. This is perfect. This tells you that our one-way street is doing its job and correctly blocking traffic from going the wrong way.
All right, last check for the NPN, and this one's a deal breaker. You need to check for any connection between the collector and the emitter pins. A good transistor should have no electrical path between them, period. So you test both ways, and you should see OL both times. If you get any reading at all, even a high one, it means the transistor is damaged. This is a super common failure in power circuits, a dead giveaway that it needs to be replaced.
Now what about the other common type, the PNP transistor? Well, the awesome thing is, you already know how to do it. The logic is exactly the same. We're just flipping the polarity. PNP stands for positive, negative, positive. This time, our negative probe is going in the middle.
See, for a PNP, it's all reversed. You're still on the diode test mode, but this time, you're going to plant that black negative probe right on the base pin. Then, you just take your red probe and test the other two pins one by one.
Then you guessed it, we're looking for that exact same healthy reading, that nice forward voltage drop of around 0.6, maybe 0.7 volts. Getting that reading on both the base emitter and base collector junctions confirms they're working just as they should.
And just like with the NPN, you absolutely cannot forget the reverse check. Swap those probes. Put the red one on the base of a good PNP transistor, and what should you see? That's right, OL, no conduction in the reverse direction, is the sign of a perfectly healthy component.
All right, you've got the moves down. You know how to test both types of transistors. So now, let's put it all together. How do we take all these readings and make that final call? Is this thing good to go, or is it destined for the electronics graveyard?
This right here, this is your ultimate cheat sheet. This is the final word. A good transistor is going to show you about 0.6 volts one way and OL the other way. Simple. If you get 0 volts or something really close to it in both directions, that thing is shorted. It's blown. If you get OL no matter how you test it, it's open, broken inside. And remember that critical last check. Any reading between the collector and emitter means it's leaking and has failed. This little table tells you everything you need to know.
And just like that, you've got it. In just the last few minutes, you've learned a truly fundamental skill in electronics diagnostics. You don't have to guess anymore, you can actually test and know for sure. You're now equipped to find one of the most common faults you'll ever come across.
So with this new knowledge in your back pocket, the next time a piece of gear dies, you'll know exactly where to start looking. So my question to you is, what's that first broken thing you're going to go troubleshoot?